right, so what is climate change? Well, climate change is when the average temperature goes up or down over a measured period of time. In fact, our climate has been changing for millions of years. You might be wondering, how do we know that if we weren't around back then? Well, scientists doing what scientists do best have been able to take hidden clues from our past history to put together this hypothesis. So if you can imagine you were a scientist and you were doing an archaic dig somewhere like, say, Egypt, and you were able to find inscriptions that showed icy times or fire or really hot times, etc. Or let's say maybe you were finding fossils and you were out in the Arctic and you found some old tree stumps or plant fossils that really don't belong there since nothing can grow there now. Or imagine if you went back to the desert and you were able to find a fish fossil. Well, fish don't swim in the desert. So you can start to see how scientists put together that our climate and our Earth has not always looked the way that it does now. But why has this happened? It's because of physics. Physics is the catalyst for climate change, much like a lot of things on our planet. Milutin Milankovitch is a very interesting man, and by being an interesting man, he was interested in the world around him. One of his great discoveries as a physician about 100 years ago was the orbital cycles of our Earth. So he came up with 3 characteristics that made up our Earth's cycles: eccentricity, obliquity, and axial precision. All of these things vary the way that our Earth orbited around the sun, changing the climate and the world around us. Volcanic activity is one way that our climate has been able to change over time. You can imagine that millions of years ago, there was a lot more volcanic activity than we get to see nowadays. And when those large volcanoes are erupting and throwing all kinds of dust and ash and sulfur, especially greenhouse gases into the air, the climate can change tremendously. We'll get to greenhouse gases a little bit further in the discussion, but this is just one of those ways that our Earth has been able to change its climate over time. Now, as we've mentioned, the sun does a great job of heating the Earth, but how exactly does physics come into play when we talk about light and heat? Well, the sun is the only external source of heat for our Earth. So, the sun, basically a large fireball of gas, is able to fire light in the form of UV, IR, and visible light, which travels to Earth over light years of time. Now, Earth, being as far away as it is, has to do a good job of balancing itself. And it does that by reflecting large amounts of this light, but also absorbing some of it as well. Light and heat. This is something that even from a young age, you could closely associate together. For instance, if you were ever to stand around a fire or put your hand next to a light bulb, you would experience heat coming from that light. Now, what you might not know is that the heat specifically comes from the infrared radiation that comes from the electromagnetic light spectrum. Now, if you take a look at the figure on the right, you'll see a spectrum of light going from ultraviolet all the way through the visible light spectrum all the way to infrared. Visible light is the light that you see, and infrared is the light that you can feel as heat. Now, going back to my analogy of putting your hand next to a light bulb. Whenever you put your hand next to that light bulb, you will notice that that light bulb is hot. And that heat can transfer from the light bulb to your hand. So whereas your hand might have been room temperature before, when you touch that light bulb and then you pull your hand away and you touch your hand to your face, you'll notice that your hand was much hotter than it was before. So we say heat energy transfers from hot to cold. So, going back to the light bulb analogy once more, we can think about you putting your hand towards a light bulb. Now, you might consider, how does light energy or infrared radiation transfer heat to something such as your hand, right? So that light energy is able to heat up the atoms and whatever is around it. For instance, a wall. When those atoms start heating up, they start to move faster, which creates heat in and of itself. And that is how you can get that heat transfer from light into something such as a wall or your hand. But let's think about it. How many TVs, lights, of course the sun, cars, things of that nature that create heat in this world, where does all that heat go? It's got to go somewhere. Now, before we answer that question, I'd like to jump over to something else that once I explain it, we'll be able to tie everything in quite nicely and help you understand the climate change that's going on around us. Carbon dioxide. You may have heard of it, and I hope you have, but carbon dioxide is a gas molecule comprised of oxygen and carbon. It's necessary for life on Earth. It's actually very important. Plants take carbon dioxide in and they put oxygen out, which, as you know, the humans and animals need oxygen to breathe. Now, carbon dioxide is also the culprit in emission of burning fossil fuels such as coal. Let's discuss more. Now, how does carbon dioxide and heat or light all tie together? I'm sure you're wondering. Well, it all comes down to the greenhouse effect. If you ever went outside on a hot day and jumped into your car before you were able to turn the AC on, I'm sure you felt that burning sensation coming off your leather seats and noticed that it's actually cooler outside than it is inside of your car. Well, this is a small scale example of what the greenhouse effect is. The greenhouse effect basically is something that traps infrared radiation inside some sort of closed space. How does this happen? This happens due to greenhouse gases, such as carbon dioxide. Now, when we go back and think about the electromagnetic light spectrum, I talked to you earlier about infrared light. Infrared light is what causes heat. And infrared light has a really hard time pushing between carbon dioxide and other greenhouse gases because carbon dioxide and these other gases are able to pack in very tight and they don't allow these long wave IR light waves to pass between. However, your other forms of light on the spectrum, such as visible light and UV light, have such a small wavelength and higher frequency that they are able to pass through these greenhouse gases. But why is that a good thing? The greenhouse effect is necessary for Earth to survive. Without the greenhouse effect, Earth would be much too cold for us to live here. In fact, it would be about 33 degrees colder, putting Earth's average temperature around 0 or so degrees Fahrenheit, which, as I'm sure if you've ever been anywhere close to those temperatures, I sure haven't, I bet you're really uncomfortable and needed a fire or some sort of heat source. But can the greenhouse effect be a bad thing? Well, if you're in the news and you're hearing about this effect called global warming, I'm sure you're thinking that it's probably not great. Now, the problem is that in our society, since the Industrial Revolution, we have created such vast amounts of technology that use great amount of energy. And all this energy that we use, as I mentioned earlier, creates heat. And it also puts off emissions such as carbon dioxide and other greenhouse gases. These greenhouse gases have a really hard time getting out of our atmosphere, with carbon dioxide lasting in our atmosphere for hundreds of years, and it has nowhere else to go. And we're seeing an unprecedented amount of greenhouse gases in our atmosphere. So, if you're following my logic, with all of this heat coming in from the sun and from all of our technology and things that we have here on Earth, and the infrared photons trying to shine back out into space, getting stopped and harbored in by these greenhouse gases, you can see how it's getting a whole lot harder where we're at. Now, if we continue on this pace, we can eventually put our atmosphere and our Earth beyond repair, causing severe damage to the world around us, which plants and animal species cannot survive on a planet that is too hot, and that's including me and you. As I mentioned, carbon dioxide has been around since the beginning of time. So the reason that our climate is changing now and why it's a problem is because of the large amounts of carbon dioxide that we are putting into our Earth. So, if we continue at this pace, what does the future have to hold? Well, according to current projections, global temperature may stand as much as 5.8 degrees Celsius above the 1990 temperature by the year 2100. And to put that in perspective, it was only about a 4 to 5 degrees Celsius increase that brought Earth out of the last ice age. Talk about a major temperature change. So, if we continue on this path in the next 100 years or less, the Earth could literally be on fire, which would lead to deserts and the inability to cultivate livestock, animals dying, and then of course, I'm sure as you know, if your AC goes out, you're going to be in a world of hurt. Now, there's another hypothesis that some scientists have put on the table, and I think it's actually quite interesting. As opposed to a massive fireball, we could actually be hurtling ourselves into the next ice age. How, you might wonder? Well, by heating up all the glacier ice caps in the northern and southern poles of our Earth, we're dumping a bunch of fresh water melting from those ice glaciers into these parts of our oceans. By doing that, we're destabilizing the natural current flow that our oceans take. If you didn't know, a lot of the water coming out of the Gulf and heading up north towards Western Europe and the UK is actually what helps stabilize the temperatures out there. So what could you effectively be doing is cooling down our Earth by stopping that natural current flow that we have now due to the lack of salinity in those northern and southern regions. And what would that do? The next ice age. So, whether or not we're hurtling ourselves towards the next fireball or the next ice age, it doesn't sound good. What humans need to do is stabilize our economy without depending so much on advances in using mass amounts of energy. Also, new science and energy efficiency would be great. Population control and things like that. But the major thing that we have to do is start looking for alternative sources of energy usage that's not pumping so much carbon dioxide into our atmosphere. The most important thing is educating your peers and those around you, as well as the next generation, so that we can preserve it for the next generation after them. Thanks for listening. I hope you learned something.